I'm not going to talk about script files because now you have already all the information you need, and you already did that multiple times. So in terms of MATLAB being case sensitive, in terms of the naming of the files, they have to follow the rules. Here, we start with something called a flow chart, right? A flow chart, which is a graphical description of the steps that you have to go through to solve a problem from a programming point of view. Why? Because when you use a language, somebody has to know what that language is before they can understand what you're trying to do. And even when they do, they have to look at all the steps and imagine in their head what the steps would lead to in terms of action. Whereas a flow chart, as a graphical description, can allow anybody to understand what you're trying to do. So in this case, just 1 second here. So in this case, you have, for example, and the symbols that you have to use is usually an oval for start and end, right? That's kind of an oval, right? And the parallelogram are for inputs and outputs, meaning that you interact with the user, asking them to enter something or whatever it is, and then what you output, what you display. That uses parallelograms. Action to be taken, they use rectangles. That means evaluate this, and so on, right? Diamond shape is for conditions. Is this true or not? Is delta negative? Yes, do this. If no, do this. And of course, in this delta means b squared minus 4ac for a quadratic equation. If it's negative, there are no real roots because they're going to be complex. And if it's not negative, that means it's positive. That means now you can evaluate the roots, and those are the roots, display them, and exit. So a flow chart may seem very simple as far as this program is concerned. That means when you look at the program, maybe somebody will understand right away from the instructions what you're trying to do. But when you have a complex programs with hundreds of lines, nobody knows, nobody's going to be able to follow, not even you, maybe 6 months later, 1 year later, will remember what every step was about. And that's why you need comments, right, in the program to remember or to tell other people what those instructions are for. Because sometimes you write them for yourself to remember, and sometimes you write them for others, because if they want to tweak that program, if they want to change some of it, they have to know what that part is about and what it does. And so a lot of people, not just students, everybody, when it's very simple, they go straight into writing the program, right? Putting the instructions together. But when it becomes a major task, then the flow chart is a must, because people will know exactly what you're trying to do. And if you make a mistake in programming, they can catch it because they will know what the steps should be, and they can follow through the way you write the instructions, whether you follow the steps or not from the flow chart. So that's definitely kind of like a universal language for how or what the program should be based on to lead to the solutions that are required. So now we're going to start with something we haven't done before, which is about logical operators, logical operations, relational operators, and so on, right? And logical variables in this case. So from a logic point of view, if you remember the first lecture when we talked about ones and zeros, we are going to be interested in binary cases. And a binary case, for example, is something true or is this something false, which we usually describe through ones and zeros. So for us, 1, true, and 0, that's false. I mean, for us is when we think true, and in MATLAB, the answer would be a 1 for that question. And if it is 0, that means it's false, right? It's not true. Remember delta positive, delta negative, right? Whether it's true or false. So first, we deal with relational operators. So in this case, this is less than or equal to, and so on. This is equal to, this is not equal to, but the difference is that here, it's about a question. It's not about equal, meaning assign the value. When we say equal, A equal to, it means assign the value 2 to A. That's all it means. But when you say A equal to, it's really about a question. Is A equal to 2? That's what equal means. It's a question, and it says, is A equal to 2? So is A less than 2? Is A less than or equal to 2? So of course, strictly less, that means less than, not equal. Equal is not part of it, right? And if you want to be part of it, then you have to say less than or equal to, right? Both of them. So, and also the not equal to, sometimes it's very difficult to handle. Sometimes I do is I change the question to equal to, and then whatever result I get, I reverse it for this kind of situation. So if I say, is A not equal to 2? And I get confused in my head, what does that mean? Is it true when it is not equal, and so on and so forth? So I'll say, okay, is A equal to 2? If it is true, then is A not equal to 2? That means it's false. So that means I just reversed the result, and I know now what the answer should be, just in case, right? If you can get it straight up from A not equal to 2 as a question, okay, fine. But otherwise, this is just a hint on how to make it easier. So for example, here, we assign 3 to X, we assign -2 to Y, and here the question, is X greater than Y? So that's the question. Is 3 greater than -2? Yes, and that's why the result of the operation Z equal 1. That means true. It is true. X is greater than Y. Is X greater than or equal to Y? Yes. Either one, right? Whether it's greater or equal, that would be fine. Is X less than Y? No, because you get a 0. Of course, the 3 is not less than this, right? Is X less than or equal to? Of course, it's false. Is X equal to Y? False. Is X not equal to Y? 1. See here? So if you reverse the operation, you reverse the result. But if you can do it straight from this instruction, that's fine, right? Now, when we deal with arrays and we deal with comparisons, because these are comparisons, right? Is X greater than Y? It does it for every element of the array. It's already built in as an element by element operation. That means is 1 greater than -1? Is 0 greater than 2? Is -4 greater than -4? And so on. So it's element by element. The operation will take place for every element of the arrays. The first with the first, second with the second, and so on. So in this case, is 1 greater than -1? True. Is 0 greater than 2? False. Is -4 greater than -4? Strictly false. However, greater than or equal to, yes, for the first one still true, for the second one still false. But now, is -4 greater than or equal to -4? Yes. It's not greater, but it's equal. So greater than or equal, that means it's both of them, right? Either one is true. And of course, if is X less than Y, you can see that the greater than or equal is the opposite of less than. Less than or equal to is the opposite of strictly greater than. Just in case, right? As you see here, 1 is a 0, 0 is a 1, and 1 is 0, the opposite, right? And the same thing here, right? X less than or equal to Y, obviously strictly greater is 1, 0, 0. Less than or equal to Y, 0, 1, 1, the opposite, right? Is X equal to Y? True only for the last comparison. Is X not equal to Y? True for the first two comparisons. But the point here of anything that you see is saying, I ask the question, and if true, a 1 will appear as a result, and if false, a 0 will appear as a result. However, now instead of the operation X less than Y, we put X and in between parentheses X less than Y. Here, this means give me the values of X for which this is true. And as you see here, X and Y. 1 is less than -1, false. 0 less than 2, true. -4 strictly less than -4, false. So the only thing for which the comparison is true is this. And what's the value of X? 0. And that's why you get a 0 here. This 0 is not about false or true. It's about give me the value of X for which this is true. Well, it's true only for the second comparison. And what's the value of X? That's the 0 here. And that's why you see here. For example, here, give me the values of Y for which X is not equal to Y. First comparison, X is not equal to Y, true. Second comparison, X is not equal to Y, true. Third one, of course it's false because -4 is equal to -4, so not equal would be the opposite, right? So you have first comparison that's true, second comparison that's true, give me the values of Y, and the values of Y are -1 for the first element and 2 for the second element. So sometimes you want to find out if the comparison is true, and sometimes you want to find out, give me the values of the array for which that comparison is true. For example, give me the names of the employees for which, you know, the average number of hours exceeds 40 hours per week. So it's not by saying it's true for these employees, you have to give me the names of the employees. And so this is how you do it, right? The operation to find out if it's true or false. And here it says, give me the value of x for which this is true. Give me the values of y for which this is true. So again, I can show you the instructions. I can show you how they operate. And we can see in some cases how they are useful. But that means in the future, you have to figure out what to use when. One thing that I also forgot to mention is that z, which is the result, well, not in this case, let's say here, for example, the result of this operation is x greater than y. Z is called the logical variable. It can only take values 0 or 1. That's it. But it's also called the logical variable, and we'll see later how useful that is, right? So in this case, x not equal to y would be 1, 1, 0, right? It will be an array made of 1, 1, 0. And that's a logical array because it's the result of some comparison. And then, because I ask for the values of y for which this is true, that would be acceptable by MATLAB. And we'll see later that if the inside of the parentheses is not a logical variable or array or whatever, it will not execute it. And here you see that the arithmetic operations have precedence over the relational operators. That means when you mix addition, subtraction, multiplication with less than, greater than, the mathematical expression would be executed first before the comparison takes place. That's what it means. So if I say 2 times 2 plus 4 minus log of whatever 10, base 10 of 10, is it greater than some other? First it will evaluate the expression, then it will compare, and the result will be a logical number or logical variable. Another example here, as you see here, or here I broke it into. First I was interested in x not equal to y. Is x not equal to y? Yes, it's true for the first comparison and the second comparison, right? They're not equal here, right? And when you see 1, 1, that means give me the value of y for which this is true, and give me the value of y for which the second comparison is true. And obviously when you look at y, the first and the second comparison involve -1 and 2. And that's why z here is about -1 and 2. However, here, in this example, just to show you that there's a precedence, and of course in this case, the precedence is the parentheses, right? There is nothing that takes priority over the parentheses. And that means, first, this is evaluated by MATLAB. Is -5 less than 2? Yes, the result of the operation is 1. Then 1 plus 6, that's 7. So that means you can mix and match arithmetic and relational operators, but just remember the priorities and the precedences, and then you can then figure out if you know what you're doing, maybe then you don't need as many parentheses in the end, right? So like in this case, -5 less than 2 first is evaluated, which is a 1 because it's true, and then the 1 becomes just a number. So and 1 plus 6 is equal to 7. So in this case, y of a, that's the same thing as saying this, right? Because if a is this, then whether I write it explicitly like this, or I write it as y of a, but with a is equal to that, that's the same thing. It gives me the same result. However, what I try to show you through the next example is that suppose I created this array made of 1, 1, 0, just like a, right? But then I wanted to find out what values of y for which b is true. It's true here, and it's true here. So that means give me the first 2 values of y, and it refuses to do it. Because you created this as an array, but it does not mean it's a logical array. When it's the result of an operation like less than, greater than, yes, it is a logical array. But here I created it, right? I created it. So it's not the result of some logical operation. In that case, MATLAB refuses to use it. Remember y of a, y of b, right? Since a and b are the same, right? No, it's not accepted by MATLAB. However, imagine if I wanted, let's say from a list, give me the first and the second element. First and second element, right? But I still wanted to use y of b to obtain those numbers, from y, the -1 and 2. because it's true for the first two comparisons, so it's negative 1 and 2. And so in this case, I still want to obtain something about the first and the second employee for whatever reason, or first and second element, whatever. And so MATLAB created, or MathWorks created, the function called logical. That means if I want to create my own array to pinpoint to specific employees, but I cannot use it because the array that I created was not the result of logical operation. So they created a function called logical, and temporarily for that situation, temporary for whatever you're trying to calculate or respond to, what have you, it will think of it as if it's the result of some logical operation. So logical B turns B into as if it's the result of a logical operation. And now I can use it to pinpoint to element number 1 and element number 2. Anybody? Questions? Answers? Can somebody tell me, again, I created Y that looks like some array that's a logical array. Seems like, but it was not a result of logical operation. No comparisons were involved, I just created it. So if I say x of y, that means give me the value of x for which y is true or equal to 1. And of course, in this case, it refuses, but I force this by saying logical y. So even though I created it, it's not the result of some comparison. It's not a logical array. But I just created this array made of numbers, which are zeros and ones. And by using the logical function, I make believe temporarily that this is the result of some logical equality comparisons. And so give me the value of x for which y is true, or y is equal to 1. Well, obviously, it's equal to 1 here. That's the first row, first column. You get this. Then it says, skip this, because I want only when y is true, right? And go to the next one. The value of x is 7. That's why you see. And again, it's column-wise. So column by column by column by column, just like we did with those functions before, right? So in this case, I ignore this term, meaning this term here, I ignore it. But now there is a 1, which means the 5 is the one that corresponds to it. And so the 5 is listed. Again, here, it's related to 6. Last column, middle row. And the same thing here. Last column, last row, and in this case that's a 9. And so you see again the operation, which is column wise. It looks at the first column, then the second column, then the third column, not row wise but column wise. And so even though we have not created y to be a logical array, I force the system to think of it as if it were. And so wherever there is a 1 here, give me the value of x that corresponds to it. 1 is first row, first column. You get this. This one here is the second row and third column, which is a 6, and it's here. Anything you got to say? Now I discuss logical operators. The less than, greater than, are called the relational operators, right? It's a comparison between two numbers and the relation between them from that kind of comparison, less than, equal to. But now it's about situations. I give you an example. I am available, true. You are available, true. The class will take place, true. If I take any other combination, I am available, false. The students are available, true. The class will take place, false. You can't have a class unless the instructor is there. And you cannot have a class unless the students are there. So this is what we call the AND operation. That means for the class to take place, the students have to be there, true, and the instructor has to be there, true. And so the idea here now of the AND operation it's satisfied, it is true only when both conditions are true. So, for example, you get a diploma, true. You got a job, true. You make money, true. And of course, in this case, to make money, you have to have a diploma and you have to work hard. And so that's an AND operation again, because they both have to be satisfied. Whereas the OR operation, either one satisfied is good enough. Either one satisfied is good enough. And it's good enough for the result to be true. And so that's the OR operation. However, that's looking at it from a logical point of view. Let's say when you deal with, if you were a computer engineer or electrical engineer, and you had to deal with circuitry based on these so-called logical operations, but through hardware, they're called gates. There, it's about true or false, 1 and 0. But in the case of MATLAB, they decided to use two different cases, or at least one case that is different from the logical thing. The number can be 0 or non-zero. It's not about 0 or 1. 0 and 1, that's the result of the operation, right? Whether it's a logical operation or relational operators involved. But in this case, the array itself, is it made of 0 values or non-zero values? The values are not important. What may be important is whether the values are 0 or not 0. So, for example, the AND operation, the result of X and Y. So forget about the logical discussion that I had minutes ago. Now it's about looking at X and Y, and if they have ones on the same spot, same row, same column, then the output is going to be true. If they don't have exactly the same situation, like both of them ones, at the same row, same column, if they don't, then it's going to be 0. So to be true, both X and Y have to be 1 at the same spot, whatever row, whatever the column, but they have to have 1. If they would have 1 if the comparison is between non-zero values. X value is non-zero and the Y value is non-zero. Otherwise, it's going to be 0. That's the AND operation. The OR operation, either one. It doesn't matter which one. Either one that has a 1 and the result is 1. The exclusive OR, the others I will discuss later, the short circuit and the short circuit OR. But the exclusive OR came as an operation that was useful in comparisons at the beginning of the digital field. So in real life, and not in real life, but in the engineering life, or the computer engineers, if you look at the table, let me just put the paper back on the document camera. So when we look at all the possible combination of A and B, X and Y, doesn't matter, right? For the exclusive OR, which is usually written this way, and if you were to use hardware, this is how you see the symbol of an exclusive OR gate. When I tell you that the output is 0 here and here, and 1 here and here, what can you tell me about what operation is being performed? That means when you look at A and B, why is the output, when is the output 0, when is the output 1? Can you describe something that is relevant? Yeah, the logic gate is this one. But I'm saying, can you relate this to A and B, the output? What can you say? How do you describe it to somebody else, what it does? How do you describe what it does to somebody else, but just words? Not 0, 0 equals 0, 0, 1 equals 1. No, in words, how would you describe this gate? How it operates and what it does? How it operates, that's irrelevant, that's electronics. But what it does. I'm giving you hints here. Come on, guys. Give me something to work with. Give me something that I can discuss. Give me something that I can criticize or accept or whatever. Yeah, but how does it show the inputs? In what context do you see the inputs affecting the output? And I have given you hints when I put those dashes, right? Let me give it to you more clearly. If the inputs are 0, 0 or 1, 1, the output is 0. If the inputs are 0, 1, 1, 0, the output is 1. But now give it to me in English. Not 0, 0, 0, 1, 1, 0, 1, 1, no. In English, just words. And to give you a hint, that was the basic gate for designing a comparator. The output, not the output stays the same. No, not the same. The output is 0. When these are equal, the output is 0. Right, Nicholas? When the inputs are equal, that means A equals 0, B equals 0, they're equal. A equal 1, B equal 1, they're equal. Then the output is 0. And when they're not the same, I know. That's why I was going to say to rephrase it, right? And when they're not the same, then the output is 1, right? And so in this case, maybe this could be the basis for a comparison, right? Because it says that if the inputs are equal, the output is 0. If the inputs are not equal or different from each other, then the output is 1. So maybe it's the opposite of what I would like to say if I want to build a comparator, right? For equality, that is, right? Because I want to see a 1 if they're equal. All right, but so I can invert it, I can do a lot of things here, right? But that means the function of an exclusive OR lends itself to being the basis for what a comparator should look like. But at least in this case, equal, not equal, right? That's all for the time being. Not greater than, less than, that's a little bit more complex. But the gate itself is already the basic gate for comparison. Because if the inputs are equal, the output is 0. If the inputs are not equal, the output is 1. So that's already a comparison that I have performed. So, but from a MATLAB point of view, now I go back to MATLAB. From MATLAB point of view, the arrays X and Y or A and B, whatever, are not about zeros and ones. They're about non-zero values or 0 values. So in this case, for example, for the AND operation, X and Y will be resulting into a 1 when both have non-zero values. So the only time you get a 1 is when both X and Y have non-zero values in the same spot. That means the same row, same column. They have non-zero values. So it's not about zeros and ones. It's about 0 or non-zero. If they're both non-zero, the output is 1. Otherwise, the output is 0. That's the AND operation. Both of them non-zero. It's like, saying, can I do the job if John and Mary are at work? Yes. So I'm going to ask the question, is John at work? Yes. Is Mary at work? Yes. Can the job be done? Yes. But if either one of them is missing or both, then the job cannot be done. Is John at work? Yes. Is Mary at work? No. Therefore, the job can be done? No. So that's the AND operation. You need to have non-zero values in both cases for the output to be 1. Otherwise, it's all zeros, right? Whereas the OR operation, so instead of seeing it from a 1 point of view, I'm going to go to the opposite. Both X and Y have to be 0 for the output to be 0. Before, both had to be non-zero for the output to be 1. Here, both of them have to be 0 for the output to be 0. Otherwise, the output is 1 of the OR operation. That means one has 0, the other one has non-zero. One has non-zero, the other one has 0. or both of them 0, right? In all these cases, sorry, it's a 1 when either both of them are non-zero, one of them is non-zero or the other. But as I said, there are 3 cases to consider which I don't like, so I'm going to go the other way. And I say when both are 0, the output is 0 of the OR operation. And so in this case, it's like saying I have John and Mary at work. Is John at work? Yes. Is Mary at work? No. Can the job be done? Yes. So that means both of them or either one of them are at work and the job will be done. And if I don't want the job to be done, that means both of them have to be not at work, right? Both of them have to be missing. Then the job can be done? No. So that's the OR operation. Where instead before we said both of them have to be there for the job to be done. In this case, we say either one of them is there and the job will be done. And so the only time for the job not to be done is when both of them are absent. So not there, from a MATLAB point of view, it's either a 0 or a non-zero value. So it's not about a 1, but a non-zero value. So when you look at X and Y, are they both 0, both non-zero? Either one of them is 0, the other one is non-zero, right? What affects the operation? And so for the AND operation, both have to be non-zero for the output to be 1. For the OR operation, both have to be 0 for the output to be 0. And for the exclusive OR, to have a 1, one has to be 0, the other one non-zero. That's the only time you get a 1. If both are non-zero or both are 0 in the same spot, the output is 0. So you see here, the exclusive OR of X and Y is 0 when both X and Y, both non-zero or both 0. Remember the exclusive OR that I showed you on the paper? They have to be equal. So in this case, it's not about 0 and 1. It's about they're both 0 or both non-zero. In that case, the exclusive OR will give you a 0 at the output. Otherwise, it becomes a 1. And so the way you also write it, you see here, X and Y with the ampersand, X segment or bar Y for the OR operation. And for the exclusive OR, you type XOR in small case, and then XY in between parentheses, right? So the others I will discuss later, right? But I'm interested in these to be used, hopefully, in cases where I can solve some of the problems. So just to give you a result of the operation, this is X, this is Y. So you see here, not X, the inverse operation, which I did not discuss. I skipped it, but it's because it's simple. It's not about ones and zeros again, right? X could be any number. However, what I'm interested in is the array could have 0 values or non-zero. Non-zero. That means I don't care if it's negative, positive, small, large, it doesn't matter, right? So the inverse operation, and that's a logical operation, by the way. That means the output of this operation is going to be ones and zeros. It's in, let me just forget about that one for the time being. X and Y. We said the AND operation, to get a 1, both have to be non-zero. Are both non-zero for the first one? No. Are both non-zero for the second one? No. Are both non-zero for the third one? No. No. Yes. Both of them are non-zero. That's why you get a 1 here. Because for the AND operation, to get a 1, both have to be non-zero. Where else do I have non-zero value? -7 and 2. Remember, they have to be in the same spot, right? Both of them non-zero. So that's why you have a 1 here. Both of them non-zero, then you have a 1. Both of them non-zero, both of them non-zero, you get a 1. So the AND operation, you get a 1 when both X and Y are non-zero in the same place. And for the OR operation, you get a 0 when both are 0. So this is the easiest way to remember the OR operation. Like in this case, is this one, both of them are 0? No. 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 Both of them are non-zero. Obviously, it's true here too. Here, it's also true, right? And so, where do I have both 0? I have them here and here. So I said the OR operation leads to a 0 when both are 0. Both are 0, that's why you get a 0. Both are 0, that's why you get a 0. Everything else is a 1. So when you try to fill a table, go for the simplest one. In the AND operation, are they both non-zero? It's a 1, and the rest is all zeros. In the OR operation, are they both 0? The result is 0. Otherwise, it's a 1 everywhere. So those are the easiest way to look at arrays and to decide what the outcome of the operation would be. For the NOT, just remember, if it's non-zero, it should have been a 1, but because the NOT is the inverse operation, it gives me 0. If it's a 0, the NOT of 0, that means a 0 with the inverse of 0 in terms of whether it's 0 or non-zero. So the inverse of 0 becomes a non-zero value, and that's why you get a 1, because here we're interested in not equal to. Not equal to, it's like saying wherever you see a 0, put a 1 in the array of the result. And wherever you see a non-zero value, put a 0. So whether you can make sense of it in terms of comparing it to what we learned before, or just applying it as is, right? A NOT operation, a 0 becomes a 1, and non-zero becomes a 0. That's it. If you remember that, then you just fill it without paying attention. Yeah, the exclusive OR. Remember what I said about exclusive OR. If both zeros or both non-zero, the array or the result is 0. Like, for example, here, first row, second column, 2 and -3. Both of them are non-zero, so that's why you get a 0. Here, you have both of them 0, you get a 0. Here, you have both of them non-zero. Both of them non-zero. Both of them 0. So in all these cases, the output should be 0, right? And that's why you get 0 here. Again, why is this element and this element through the exclusive OR leading to a 0? So again, what would be the reason? Based on what I just said. Come on. Is anybody around? Genuine. Why do I have a 0 here in the result for this and this comparison? Or, not comparison, operation. The exclusive OR, supposedly. Because, Genuine, say something so I know you're there. Still waiting for an answer, Genuine. You better say at least you're present. Because last time I thought you were absent. Ah, good. So can you tell me why this number and this number, when involved through an exclusive OR, lead to a 0? So again, I remind you, I get a 0 output for the operation when what? In this case, and in this case. What I said is I get a 0 as a result of the exclusive OR operation. In this case, and in this case, what do they have in common? Meaning, you can hear me at least?